I show you DC-Infilt now. With this program, infiltration installations can be calculated according to the code of practice, DWA A 138 of the German Association for Water, Wastewater and Waste, or like a method according to have ans. And for the webinar, I show you an example from the code of practice, which is already open here, which you can see, a true drain trench infiltration. Yeah, there's a huge range of different infiltration types available, which you can choose here in this drop-down list. Yeah, like area infiltration, trough infiltration, drain trench infiltration, also like with canal and block. And then we have the well infiltrations according to have-ons, or like horizontal drains and infiltration basins. But we choose this one here now. Oh no, sorry, this one. Yeah, like first you need the rainwater quantity, which you can find in the settings over here, rainwater quantity. And the rainwater quantity is always specified for a certain location for the duration between 5 minutes and 72 hours, and for the 3 different frequencies over here. So you can probably already choose desired and safe location in the drop-down list over here. Like we choose München here. Or you can set up some new data. Like you can import with paste over here some data from the KOSTRA Atlas. Like we use the water quantities from the KOSTRA Atlas in Germany, but it does not offer the quantities for any other countries. So I don't show it here now. Or you can enter your values manually, like you can change them like to any other values you already have. And then we say, like we choose München now for this example, and we say, okay. And we offer 2 infiltration types. The precipitation over here, which is with the rainwater quantity, or the present influx. So yeah, it's with the influx and with the duration of the days, like in days. And like, for example, like if you have a pit and you have a certain amount of influx into the pit to infilt, like rainwater, like influx from rainwater to infilt, then you can choose this option. But we go back to the first one. Yes, and with this rainwater quantity, the program calculates the dimensions for the hollow and the drain trench, which you can see in this table. And yeah, it's calculated for the given data like permeability for gravel here, and for the area, the groundwater depth, and yes, all the data which you must enter is summarized at the top of the sheet. And the results are shown below the graphic. Yeah, the table shows here that the 1 hour rain is relevant for the hollow. So like where the volume is the greatest for the hollow. And the length of the drain trench is the greatest for 24 hours. And the calculation is mainly dependent on the unpermeable area, which you can enter here. You can either enter a complete area, which is shown here, like 2,000 square meters, or you can split this into partial areas with calculate. So we can choose for, like, first we say like the first partial area is 500 square meters, and then we can choose a type, like a kind of a surface. And as you can see, like there's a huge amount range of points where you can choose from, and each area, like type of area, is deposited to a flow per meter, and we choose the inclined roof for the first area, and then you can see like it shows the belonging flow per meter. And then we have a second area, which is 1,200 square meters, and we choose a type as well. And we say it's a street, path, places, pavement with dense joints. And we say okay as well. And then it would be like 1,700 meters, but yeah, with the flow per meter, the unpermeable area is 1,400 square meters. So like both areas times the flow per meter reveals the total unpermeable area, which is shown here then. And then the volume and the length are calculated again, but this table is like too big now for the first page, so it's shown on the second page. Yeah, and next to the table, you can see the other results from the calculation, like the calculated infiltration area, or like the required storage volume and the pointage height. Additionally, it's proved that the drain is empty within 24 hours. So it takes like 2.3 hours to get it empty, that all water is infiltrated into the ground, and this is less than 24 hours. This must be because like it could be like rain more often into 24 hours, so it must be empty in a certain time, which is 24 hours here now. And then in the graphic, like we can also see the pointage height over here. And it's also, we can see the dimensions of the hollow over here, which is calculated with the required volume. So the hollow has a width of 1.5 meters, 50 meters, and the height is 1 meter in this case. And then we can also choose a different type. We choose the canal block drain trench infiltration, and I can show you how the block drain trench works. We choose this one here. And then you also have like a huge range of deposited blocks in the drop-down list. And we take the Rigofill block here, and you can see the length, the width, and the height, and the storage coefficient. Yeah, all are deposited to a block, and yes, you can say okay, and then you already can see like that the width and the height must be a multiple of the block size. So the width was 80 centimeters, so the width of the hollow must be a multiple of the width of the block, which is 1.60 meters here in this case, and so it must be 2 blocks in width, and in height it must be like 2 blocks. And then we go to the second page, where you can see the amount of blocks. So in this case, we need like, which we have already seen, like 2 blocks in width, 2 blocks in height, and we have a huge length. And we need like many blocks in length, like 157. And with all those blocks, the required storage volume is covered to infiltrate the rainwater volume. But then we go back to the other infiltration type, the trough drain trench infiltration, because I want to show you the add-on option DC-Infilt rain. It can be used to check whether the treatment of rainwater must be considered. It's according to the code of practice, DWA-M153, and we can apply this one, and then it the verification is already shown in the results. And yeah, this code of practice is from the German Association for Water, Wastewater and Waste. Again, yes. Yes, then you can enter specific information for the partial areas. Like this one we already have filled in, like before. And then we have like the more informations for the handling of rainwater. So this one is the part for the influence from the air, like what kind of pollution you have in your environment. And like if we click on this one, we already see that we have several options here available. And each option has a specific amount of points, where you can see here. And the amount of points increases with a greater pollution. Like the pollution on a residential area is less than the influence of the area of a business and industry area, which has like 8 points, and this one has 1 point. So we choose the residential area with a medium volume of traffic, and we choose this one. And for the second area, we choose the same. And then we can make more specific information for the surface as well. And yes, it's the same here with the points, it increases with the pollution. And like the first area was a roof, so we choose the roof area. And we say yes, okay. And the second one was a street, path places, pavement with dense joints. So we use the code areas here. So all points are set here. And yes, and those like points are summed up, and it's it reveals into the sum of drain load B. And that we can like compare this drain load, we must set the waters. Like the waters is like where the rainwater should be discharged. And there's a huge range where we can select as well, as you can see here. And the water points decreases to the sensitivity of the water. So like if you have a sea, like it has a huge amount of points, but when we have a very sensitive water, like we have obviously no points, like yeah, should not get any like wastewater into the sensitive water. We choose a water course, a small river here in this case, and we say okay, and this has like 24 points, and the verification says like that the drain load B must be less than the water points G, which is fulfilled in this case. So the verification says that there's no handling required. And then we can also set the passage values, which is the second verification. Then we can make a selection again, and we say like we have a pavement here, which you choose now, and we say okay. And each like where we can see like that it has a passage value, which is deposited to the selected surface. And we say okay, and this passage value, which is like deposited for the surface, must be less than the acceptable value of passage, d max, which is G divided by B, which is 1.91. And yeah, like D is less than D max, so the verification is fulfilled as well. And when we go back to the graphic, there's one more option, like when you have an impermeable top layer like clay, you can say that the infiltration just goes over the base, which you can add here. So yeah, if you don't have infiltration over the side, you can just add this one, and the calculation will just go with the base.